like we reached the conclusion that this should have been a 1, and that we're evolving about the y-axis, the region depicted in red over here. And you said you knew how to solve this using the shell method. By the shell method, you normally think of or draw typical shells that are parallel to the axis of revolution. So there's a typical shell, and its width is dx. Here's another typical shell. Again, parallel to the x-axis, parallel to the axis of revolution, sorry. And so you're right. When you're using the shell method, you want to integrate along the axis that the shells are perpendicular to, which would be the x-axis. So the problem with the washer method is that if you think of a typical radius for the disk method, I should say, the formula for the radius of the disk is different depending on where you are. So for the disk method, you want your typical radius to be perpendicular to the axis of revolution. So there's a typical radius. But when you get on the other side of this red line, the formula changes. So you actually need to use 2 definite integrals to evaluate the volume of the solid by revolving about the y-axis if you're going to use the disk method. And I'll go to board 2 and show you what it looks like in just a second. But the idea is that from 0 up to the square root of 2 over 2, a formula for the radius of the typical disk will be in terms of x, in terms of y rather, it'll be just y, because that's the coordinate of a point along this straight line. The coordinates of this point right here are x comma y. So for each y coordinate along this segment, the corresponding x distance will be x. But that changes up here. The coordinates of this point will be based on the equation for the area, the equation of the circle. So let's go to board 2 and I'll show you what it looks like. So here is the solution using the shell method. I'm sure this is what you set up. This is the answer that you gave, and that seems to agree with what I did on Wyzant here using the shell method formula. This is outer radius, I'm sorry, the top of the shell minus the bottom of the shell to get the height of the shell. Now here's what we have to do for the disk method. Pi times the radius squared. Well, we saw that the radius from 0 to radical 2 over 2 was y. Radius squared was give us y squared. And then here's the second integral, where we're using the equation for the circle, plus pi times the definite integral from radical 2 to 2 to 1 of the square root of 1 minus y squared. That's the radius squared. And you can see we get the same answer as we did with the shell method. So I'll leave it to you to actually evaluate these 2 integrals by hand. I'm assuming you were just having trouble setting up the integral. So there you go.